Hi all, this is Uttam Singh from Solar Pivot Power. So this video is about solar tracking and the impact from winter and summer solstice. In scientific terms, this video is about the relevance of angle of incidence. Winter brings unique challenges if you're looking to maximize your solar power production. Winter days are of shorter duration and the sun stays much lower in the sky. Optimally, the solar panel should be placed at a steep angle during winter. Also, the rate of rotation needs to adjust to shorter daylight hours. For the Northern Hemisphere, there are 4 significant solar days during a calendar year, known in common nomenclature as the solstice and equinox. Winter solstice marks the shortest day and the sun is at its lowest point in the sky at solar noon. Conversely, summer solstice marks the longest day and the sun is at its highest point in the sky. The equinoxes mark equal day and night durations. As a reference, let's take a look at the solar path during summer and winter solstice days at Dallas Airport. This data is from SunCalc App. That's a wonderful free tool, and I'll leave a link for it in the description. As you can see, on winter solstice day, the sun peaks in the sky at solar noon at an altitude angle of 33 degrees. On summer solstice, the sun appears almost directly on top at 80 degrees. Let's look at the relevance of angle of incidence and the solar radiation that a solar panel can convert to useful energy. Quite simply, it's the angle between solar rays and an imaginary perpendicular drawn from the solar panel plane. The smaller the incidence angle, the more direct the sun rays on the solar panel, and hence higher power production. Here's a quick experiment using our Smart Tracker. The Smart Tracker provides 3 user configurable tilt settings. This allows a user to tune optimal solar production depending on the latitude and time of the year. On this day, we had good sun and temperature in the 60s Fahrenheit. Here's solar data from the SunCalc app. The solar panel was set at 3 different tilt angles, and peak power was measured while rotating the panel from sunrise to sunset positions. Since we are close to the winter solstice, the sun stays quite low in the sky. On this day, it peaked at an altitude angle of 38 degrees. Peak power of 97 watt was observed at 55 degree tilt, 92 watts at 30 degree tilt, and 62 watts at 0 degree. I also attached an endoscopic camera to the solar panel to get a visual perspective from its point of view. As expected, 55 degree tilt resulted in a much more direct exposure to the sun. Thank you for tuning in. Please like and subscribe if you enjoyed the content. We are working through our final design of Smart Tracker. If you're interested in additional details about our upcoming offering, please leave a comment or send an email to sales@solarpivotpower.com. And as always, a big thanks to our Solar Stakes customers. We are thrilled at the positive response this small offering has received. You'll find a link to a 25% off coupon in the description.